Hi, welcome to the Midlife Lab. I thought I'd bring out this project. I actually started building this before I decided to video any of my exploits. So yeah, I thought I'd get it out and just give an indication of where I'm going and the sort of work I'm doing. Now this unit, a bit interesting in that it uses the CD4046 CMOS PLL as its frequency generating component. It's a little unusual because normally a PLL would be set to a center frequency, and then the phase comparators would just adjust that very slightly to keep it in lock with an incoming reference frequency. So it'd normally be working over quite a small range. However, in this one, Thomas Henry has used, abused, tortured this poor little CD4046 to generate signals over a much larger range. So this is a rough block diagram of the CD4046. Got the VCO, whose frequency is set by the capacitor and resistor pair. This resistor down here just allows you to do a bit of an offset. Got the phase comparators, there's actually two in there. Signal comes in at the top, and part of the VCO signal is fed back round and into the phase comparators. Comparing that with the signal in, you get an error voltage which is fed round and back into the VCO in, which adjusts the frequency of the VCO to bring it into lock with the incoming signal. Now, what Thomas Henry has done, instead of having the VCO in coming from an error signal, he's tied that straight up to VDD. Instead of having the resistor on pin 11, still got the capacitor, but instead of the resistor, he has a transistor pair outside doing a voltage to current conversion. And that current is fed into pin 11, and it's that which helps to adjust the operating frequency of the VCO. Now, normally the output from the VCO here is a square wave. What happens is when the pulse there is high, pin 6 gets tied to 0, and pin 7 has a linearly ramping voltage on it, so it creates a nice little sawtooth. When the VCO output goes low, it swaps over. 7 gets tied to 0, and 6 has the ramping voltage on it. So you get two like half sawtooth waves being produced depending on the state of the VCO out. High, 7's ramping, low, 6 is ramping. So instead of using the pulse that's coming on VCO out, the signals are picked off these two pins, and those are then combined to produce the various waveforms. That's the signal generation side of it. And these two quad op amps are then used for various waveform shaping circuits to create the output waveforms for this. The output we have from the CD4046 are two half sawtooths, I suppose you would say. Those are combined to form a composite sawtooth wave. Oh, little purple one down here. To form the triangle, one of those half sawtooths is inverted and then offset, and that is combined and pushed together with the normal half sawtooth, and that creates the triangle. Because of the way this happens, you do get this little very high frequency spike where the two parts of the waveform join. It's so far out of the audio range that it's not noticeable at all. The triangle then goes through some shaping circuitry to form the sine wave. The sine then goes through to a comparator where it is either combined with a set voltage or a variable voltage to provide a width controlled pulse. This is a quick view of the sawtooth generated. Quite a nice sawtooth. But there's a little bit more. The sawtooth and triangle go through a skew control and get combined, which produces a rampoid. So it goes from the sawtooth through some weird conglomerate and up to a triangle. And back down again. The triangle is actually quite nice, apart from that very quick pulse at the top. But we can see it is very fast. Measuring the width on that, it's showing as just about 1.5 microseconds across, so it's well up into the hundreds of kilohertz. So unlikely to cause any problem. Well, I've never heard any problems with it. And that then gets formed to produce the sine, which is quite nice. I mean, it's never going to be as nice as a vine bridge, but that's quite nice. We'll notice the little connection artifact barely shows up at all on this, and there's and finally we have the pulse. The comparator that generates this can be fed with an external signal, so it can be pulse width modulated. But it do have manual control as well, and we get the duty from, well, we would get the duty if we lock it, from a duty cycle of just under 4%. Up to about 90%, quite a useful range. And of course, if you want to be boring, you can of course have a square wave. Yeah, the triangle's formed by putting together one of the half sawtooth waves with an inverted form of the other half sawtooth. And we can see how they can come together. We've got the two halves there, one inverted, and then it just needs to be brought into level and a little bit of adjusting to make sure the connection points are good. And there we have our sawtooth, and there we have our triangle. Yeah, of course there's going to be lots of little bits of fiddling around here. You're just getting that last little bits of symmetry in there. And likewise, the symmetry of the sine wave can be adjusted to achieve. Getting the best possible balance between shape and actual symmetry. And of course I have this linked up to my power supply, and so we get up to just over 18 kilohertz. And if we go right down to the bottom end and actually take it right down, we get it to around about a cycle every 6 seconds, roughly. Yeah, if we stop it there, let's so 7.5 seconds. So one cycle every 7.5 seconds. So it's versatile. It goes from very low, useful as an LFO. Obviously not intensely low, but usable. Up to 18 kilohertz, which is probably pushing my hearing somewhat. I wish. So yeah, quite simple, very versatile, and I'm looking forward to having a play with it. So yes, this is going to form the heart of my first synth voice. I've got a little case to put it in. I'm currently working on a transient generator, just a simple ADR, not even ADR, an AR transient generator, just for producing some notes. I'll be putting that together with VCA, voltage control filter, possibly an LFO and another VCA, and we'll see what sort of noise we can make with that. And that, hopefully, is going to be just the first part of my synth voyage. So if you fancy coming along, it'd be great to see you. Until then, be seeing you.